Hello, welcome to the meeting today. I don't think anyone's going to show up, so I'm going to go over some things and I'm going to talk about a number of papers and catch everyone up to speed on the latest developments. So first we're going to do a Slack review, and there's actually been a fair amount of activity in the Slack this week, so hopefully we can talk a little bit about those things in more detail. I can talk about some of the things that are just kind of posted in there without explanation. And then we can move on. And if someone shows up, then we'll have a little bit even more conversation, and we'll keep moving like that. So let me share my screen. Okay. So this is our Slack review. Here's our orthogonal lab Slack. The first one, actually, this week finally we had some activity in the Brain Organoids channel. And this was due to me attending a seminar on brain organoids yesterday. It was a very good seminar. They talked about a number of things that are going on with organoids. So again, organoids are these things that are created from neural stem cells. They put them in a three-dimensional culture, and they can grow them from a single cell. They can grow these large agglomerations of cells that are called organoids. They're not really brains. But they were other organs, but they have sort of the similar cell types and similar types of functions, rudimentary functions of those organs. So not only are there brain organoids, but they're mini guts and other things that are sort of approximate the biological organs that we have in our bodies. And this is an organoid emoji. So I've been putting emojis in the Slack for people to see. For people to use for different things that you wouldn't think exist. So there are all sorts of nice emojis. If you go to the emoji button and you look and you scroll down towards the bottom of the emoji list, you'll see some of the custom emojis. In any case, we have a number of papers. So this is a nice one, I think, for people who don't know too much. Well, there are two papers that are for beginners in this area. This is a core concepts paper from PNAS. Organoids have opened avenues into investigating numerous diseases, but how well do they mimic the real thing? So this is a paper that considers, organoids. This is a picture of an organoid here. I've tried to draw these in lab meetings, and I don't think they have any distinct shape. That they're just kind of these a bunch of blobs of cells stuck together, but I guess you can grow them in different shapes if you use scaffolding, but this is what they kind of look like. So you can grow these freely or on a scaffold, and so the question is how well do they mimic the real thing? So this, in biology we also have models, as we do in computation, and organoids are a model of a organ, basically. And so the question is how close to the real thing are organoids? And so they consider that question in this paper. They kind of go through the field. It started in the 70s to the late 80s. This is where people were kind of playing around with, people have been doing a lot of work on cellular reprogramming for decades, and they've gotten to a point in that field where they've been able to get really predictable reprogramming capabilities. They've been able to take somatic cells and turn them into stem cells, or other types of cells. So you can control the differentiation of the cells. You can control the creating stem cells from differentiated cells. It's a pretty controlled process at this point, but that's only for sort of single cells, or what they call a monolayer of cells. When you're talking about these organoids, that's a little bit different. And so that's what they've been doing in maybe the last 20 years, is kind of working out these details. And so they're used as models of diseases, so you can make like a mini brain or a brain, and you can do all the sort of genetic engineering you usually do to a single cell. You can start an organoid from a single cell and grow them up into these little organs that you can model diseases in, like Alzheimer's or other types of things that you couldn't necessarily study in an in vitro context. So you couldn't really, take someone's brain and slice it up, I mean, they'd have to die first, or you'd have to harvest a bunch of mice. In this case, you can do specific, what they call knockouts of different genes, where you take them out of the genome, and you can then grow the organ as if it, had that knockout natively. It's much easier to do than working with animals, and it's much more efficient because you don't have to harvest a bunch of, mice or rats. You don't have to wait till someone dies, and you don't have to, you can do imaging, but the imaging is on these organoids. So the idea here is, how close are they to the real thing? And they're not the real thing, in fact, but they do serve a purpose, and that purpose is to model diseases, model the organ. And so this is kind of, we know this from computation, that it's not the real thing, but it can be very useful anyways. So this is another paper here if you're interested in sort of the model systems for human biology aspect of it. So this is human organoids, and they talk not just about brain organoids, but other types of organoids. So you can study, say, for example, the liver, or the kidney, or even the lung. Here's their image of an organoid. It's kind of almost like a starfish, but it's, I mean, these things, again, they can take on a lot of different shapes. And so they kind of go through model organisms here, which are used for human disease. It's interesting that a lot of the model organisms that they use for human disease that are the most informative sometimes are the very phylogenetically distant from humans. So like yeast, or C. elegans, the worm, or D. melanogaster, which is a fruit fly. You have all of these different model systems, and the reason they use model organisms that are so much different from humans is because they can actually look at the genes, and the genes are homologous with human genes. And some of the processes, like in C. elegans, where you're looking at aging, they're similar processes. They involve similar genes that are homologous. And so you can actually get a pretty good handle on some of these processes. But actually with organoids, it's interesting because you have what is essentially the same genome as humans, but you have this portability of a model organism. So it really does help us get a lot closer to the human condition in terms of the, having a background genome that's very similar or identical to the, the context you want to study, and then the gene expression as well would be somewhat similar. I mean, we don't know, because we're building these organoids from a single cell, whether they really mimic what's going on inside the body and in the context of the body. So that's still, an issue, but it's a lot closer. We get a lot closer to that answer than we do with some of our model organisms. And so they kind of go through these differences between human and mouse stem cells. They ask a lot of questions about like iPSC, which is the induced pluripotent stem cell technology, and how close that is to what we want. So people use induced pluripotent stem cells to look at different diseases. But again, this is like single cells or monolayers of cells, and you only really get the inside of a cell or a cell population. You don't get the inside of the organ. And so that's where the advantage of that model comes in. The other two papers here, I put this comment here. This one might be interesting in the context of metabrain models. And what I was thinking here is that these papers talk about in organoids you can grow not only large sort of mini organs with a lot of cells and a lot of cell types that are similar to humans, so you can study disease, but you can also model layering. And this is something, if you go into this, the metabrain models paper will be out pretty soon, so I'm not going to spoil it for people. But in the paper, we talk about something called layering and something called encasing. And so this is a very important part of metabrains. And this is a computational model of different representational layers in a sort of an artificial nervous system. But in biology, we have this principle, and I've been trying to find a good review, and I haven't been able to find one. So maybe this is an opportunity to, write a really novel review. But there's a, what you can do in these organoids is you can build layers of cells. So you can actually, here we have sort of cortical layers. So in mammalian neocortex, you have your neocortex that has what they call 6 layers. And the 6 layers are just different arrangements and types of cells organized by layer. So you have layer 1, layer 2, layer 3. And they're all sort of layered in a laminar fashion on top of one another. And the important thing here is that they're actually connected up and down the column. So it forms a column between the layers. And these different cell types have different functional roles in terms of processing information. So you start at layer 1 and you go to layer 6. And there's a lot of difference between what happens at layer 1 and what happens at layer 6. And these layers then are functionally sort of interdependent, but they're also functionally distinct and structurally distinct. And so, the people at Numenta who do a lot of stuff with hierarchical temporal modeling, they talk a lot about these cortical columns as being like a sort of a candidate mechanism for information processing. You can build an artificial set of cortical columns to solve computational problems. So it's a nice alternative to AI. But the question I'm asking here is a little bit different, or I'm posing. And that is, can we mimic this layering, this more general layering capacity of biological systems? So, you see that layering not only in the neocortex, but you see it in a lot of other parts of anatomy. You have embryos that have 3 layers, for example. You have your arm. Your arm consists of bone in the middle and different layers of bone at that, and marrow. And then you also have nerves, and you have fat, and you have muscle, and you have skin on top. And so all those things are layered, and there's a functional reason why they're in the order that they're in, but there's also sort of they're interdependent. Your bone actually shapes the way you can move your arm. The way your muscle connects to the bone or lays on top of the bone also determines how you can move your arm. So all those things have sort of a dependence, a functional dependence. And so that layering is important. And then the encasing aspect is important too, because we can take the layering and create a situation where we can have more complex topologies. So we can have these layers. And let me actually go to my... Okay, so if we're looking at a set of simple biological layers, like I showed in the organoids, you have something like this. The layers are laminar, which means that they have this structure where there are no gaps in between them, and they're just kind of laying on top of one another. And, they have different properties. So this one is a certain cell type. Maybe this is another certain cell type. And then this is yet a third cell type. Or it could be the 2 cell types with another cell type sandwiched in between. The point is that they have this laminar structure and that they have this sort of layering capacity. Some of this is the product of what they call reaction diffusion and morphogenesis, which forms these layers organically, but also there are a lot of functional aspects to them. So we showed that picture of the cortical layers. And then this is just a generic set of layers that have some functional relationship between them, but also have functional relationships within them. So the layering is very important to their function. And so that's layering. Okay, so that's layering. Then you have encasement, which is where you have layering with some sort of topological manipulation. So if we go back to this layering, we can have a 2-layer thing here, where we have 2 layers, and they're different in some way. They're composed of different materials. But now let's say that we have encasement. So how does encasement work? So let's suppose that this layer moves this way, and then this way, and then this way, so that it effectively encases the second layer to an extent. So it would look like this. This is getting a little bit messy here, but you can see that there is this now, with these movements, you get this encasing of the second layer. And so this also has functional properties that are interesting. You see this a lot with in development, where you have different layers of tissue moving over other parts of tissue. You have this in biological systems with in respect to axons that project out, like axons of motor neurons. You have a myelin layer that overlays the axon, and it acts as an insulator, but it actually acts as a conductor of saltationist conduction. And so these are all different ways in which you can have encasement. So the layers are kind of stacked in a laminar fashion, but then those layers can fold over. And we know this happens in development all the time. You have folds and bends in terms of different layers of tissue, different cell populations that form these layers, and then they fold up, and you get these different types of geometries in development. And so, what is the sort of the functional significance of that, if any? And that's kind of what I want to get at with a lot of this question, and maybe following up on the MetaBrains paper. So I don't know if they really talk too much about layering here. They kind of talk about it in terms of different tissue types sort of forming in these organoids, but they don't really I don't think they get at that core question, and that's the question I want to pose. And if my board were working, I could sort of put it on the board and have something for record here, but I can't do that right now. So that's the Brain Organoids channel. Check that out. So a lot of you aren't involved in that channel, but you should be. We sometimes post some really interesting things in there. I'm not sure if we have anything. Let's see, cognitive futures. That's old. Cybernetics might have something. Okay, so in cybernetics, I actually posted a book in this channel, and this is Ashby's Design for a Brain. And this is an old book on cybernetics. This is W.R. Ashby, who is a pretty big name in classic cybernetics. This was in 1952. And he published this book called Design for a Brain. And Ashby was a psychiatrist who did a lot of work with cybernetics, kind of thinking about how the brain is this regulatory engine. You can see this is a scan of an old book. So, and it's kind of weird because the title page is way down here. But anyways, he wrote this book and kind of like goes over a lot of his ideas about the cybernetics of the brain. And actually, if you read it, you'll find that it has a lot of, it looks very modern in terms of what people are thinking about, but this was written in 1954. So let's see if we can go to the table of contents here. Okay, so, he's talking about dynamic systems, which are sort of like dynamical systems of today. The animal is machine. He talks about parameters and step functions, which are very similar to the kinds of things we talk about in terms of neural networks. And then he talks about the ultra-stable system, ultra-stability in the living organism, something called fully connected systems, which are where you have these networks that are connected in different ways, and that there's a high degree of connectivity between nodes in the network. And this drives a lot of the aspects of the brain that he finds that are, that we're all trying to understand. So, the idea that you have to have this connectivity for the brain to be, a powerful information processing engine. But there are different types of connectivity that, maybe are more important for, say, robustness or stability. And so he gets into that as well. Gets into disturbed systems and habituation. So there are a lot of these things like, things from maybe behaviorism like habituation. He's tying it to systems level phenomena like disturbances and iterations and independence and multi-stability. Now, one of the things that he does in this book, and I don't think there's a picture of it here, but he comes up with this sort of machine called the homeostat. And the homeostat is this little, it's not really even a robot, it's kind of like an automata machine. And it's one of these fully connected systems that don't really do anything interesting, but they do sort of regulate themselves. And so this is something he brings up in the book. Like I said, I'm not going to go through the whole book because there's a lot here, and I don't know how it's scanned in here. But he does talk about the homeostat a lot throughout the book. And he talks about these regulatory systems. And so one of the things I like to talk about sometimes in talks is this idea of the closed feedback loop in the way that Ashby envisioned it. So one of the things that Ashby talks about are these models of augmented intelligence. And so what is augmented intelligence? So we start off with two boxes. This is what we might call the brain. This is what we might call the environment. And so you have this brain and environment, and the brain has to interact with the environment in some way. So the brain generates something that acts on its environment. So in this case, what Ashby proposed was that there's this feed-forward signal from brain to environment, and it's characterized by this parameter G. Now G represents intelligence, and of course we can debate about whether that's a fair characterization of it. G, of course, is a single parameter, so it has to capture everything that the brain is doing in terms of its behavioral output and mapping it to the environment, which is maybe a bit naive, but that's the way he can sort of formulated this. Then there's a feedback that goes from environment back to brain, and that is some sort of, well, we don't really know what it is. I guess it's a direct perception or perception, which is P. I can't remember the actual parameter that Ashby uses for this. I guess it's X, which is like kind of even more nondescript than P. But X just basically means that the environment is having an effect on the brain. So X could be like some direct perception, or it could be some sort of like influence on the brain, maybe through stresses or some, even some simple stimulus like a light stimulus working on B, and then it's generating something internally in B, and then it's generating this G, and it's having an effect on the environment. So you're acting on the environment is acting upon you, and there's this closed loop feedback. So the idea that Ashby had was that you have this sort of loop, this closed loop that acts as an amplifier. So you can actually amplify intelligence, G, by interacting with the environment, getting information in X, and then G being stronger, and then acting on E, and so forth. Ashby also had this model of augmented intelligence where he thought that you could optimize it. So there's this inverted curve, and this is something called the it's a curve for arousal. And so the idea is that you have this curve that has an optimal point in the middle of the distribution. So the idea is you have suboptimal arousal down here and down here, but you have optimal arousal up here. And this is all controlled by G. So this is a very nondescript function. It's sort of based on this model of arousal, but it's basically supposed to represent any type of like output of G. So this is like FG, this line here. This is the optimal operating area here. These are the suboptimal operating areas here. So the question is how do you keep your behavior or your G output balanced between in this region of this curve? And so this is another aspect of this. It's not just that this is a closed loop feedback system. It's that there's feedback that regulates the system so that it stays within the parameter values of interest. So G can increase, but G also can decrease if it gets too high. And so this may actually require more than a closed loop system, but in Ashby's mind, this was sufficient for this balancing, keeping this thing within the optimal zone. Interfaces today, this simple closed feedback loop. But I don't think people have looked at it in different ways. I think they've looked at it in the sort of implementation step where they've taken that basic model and they've turned it into a brain-machine interface. But I don't think that people have talked about it too much in terms of like how it can be more complex or what some of these things mean. Taking G as a measure of intelligence and interrogating that measure. So it means that you have one parameter G, but maybe that's not the way to measure intelligence at all. Maybe it's a much more complex thing. Maybe it's a different thing altogether. What would happen if, for example, if we replaced intelligence G with some other parameter, or maybe we just simply looked at intelligence in a different way and said, maybe it's all about direct perception, perhaps. So you'd have direct perception maybe is the thing going from the environment to the brain, and maybe the brain then imposes feedback on the environment. And that would be an interesting way to think about it. So there are a lot of ways to think about this. And again, my board's not working right now, so I don't want to, I can't draw what I want to draw, but that's okay. We'll talk about that maybe in another meeting. So I don't know if we have anything else in this section. I don't know if Ethics, Tech, and Society has anything. Oh, this is nice. There are a couple things in this channel. So we have, so this is something that Jesse pulled up. This is for Aaron specifically, but anyone's welcome to look at it. I think you'd particularly vibe with this, and this is something called The Future of Work. It's a story at Stanford HAI. They're talking about robotics and automation and how they might kill jobs, how they might, work against it, what they call human-centered workplace. So, what we need to do then is to rethink AI-driven automation. So you have a lot of automation in the workplace now. And is it working for or against humans in terms of working, getting their job done? One might argue no. The idea of a lot of the automation, of course, is to make people's lives easier, but of course it doesn't necessarily do that. And then there are all these social issues that involve automation and replacing human labor and things like that, that we were talking about a little bit last week with universal income and things like that. But this is, you should read this article if you want to know more. Then I found this abstract, or this syllabus here, Algorithms and Inequality. And this is this is something that Radia Ababe, I think I'm pronouncing her name right, is the professor on, and she's a person in AI ethics. So she's doing this seminar at Cal Berkeley on algorithms and inequality. And it says that algorithmic tools have an immense impact on every aspect of our lives, from decision-making and education to health and criminal justice systems. While algorithms are poised to transform many domains, recent discussions have also brought to light a disconnect between individuals who introduce and deploy algorithmically informed solutions and those who regulate policies surrounding these solutions, how these solutions are used. So this course is going to go into some of this. It's a lot of the topics that you encounter in the AI ethics literature, but and so this, to sort of get a feeling for this area, she recommends reading this paper, Rules for Computing and Social Change. So this paper here, and this is an archive paper. So this is where, there's this recent normative term in computer science has brought concerns about fairness, bias, and accountability to the core of the field. And so they kind of go through computing as a diagnostic. Computing can help us measure social problems and diagnose how they manifest in technical systems. Computing is formalizer. Computing requires explicit specification of inputs and goals and can shape how social problems are understood. So you can formalize a lot of things using computing. And this works against vagueness, which sometimes is an important political tool. Now, that being said, there's a nice literature on vagueness in computing, but this would require, this isn't in the mainstream of computer science, so sort of require people to, think specifically about these types of issues. Computing is rebuttal. Computing can clarify the limits of technological intervention or technical interventions and of policies premised on them. Computing is synecdoche. Computing can foreground long-standing social problems in a new way. And I think this gets to a lot of the automation and inequality stuff that that article that we talked about just before this one talked about. Yeah, so this is a nice paper. You should read that and look over the syllabus here. I don't know if there's more coming here, but we'll keep an eye on that if you're interested. So that's our Ethics, Tech, and Society, like 2-minute roundup. Let's see if we have anything in game theory. Nothing in game theory. In general, we have Jesse attended a workshop on IEEE COINS, which is this conference on omni-layer intelligent systems. I think they just wanted to make that COINS metaphor work, so they put IEEE conference on. But anyways, so he went to this cognitive environment track. I don't think he reported a lot, at least not in this channel on it, but it's, wanted to check it out. So you might want to check with Jesse on this for more information. He also said, I will be doing some administrative work this week in organizing projects and curriculum. I don't know where he is on that, but I'm sure he's working on it. So, as a general reminder, let us know if there's something in particular you have a desire to learn, would want to take a leadership role on, or have a particular interest in for the lab during the next few months. Or if you know anyone who would be a good fit in the lab, let me know and I can reach out to them and recruit them. So this brings up another thing we've been talking about on it with respect to different roles in the lab and getting people on board who are specializing in certain roles. So I'm interested, for example, in a role called model builder. And so model builder is a specific role where you would basically implement ideas. You would learn in this role how to take an idea and implement a model around it. So, taking an idea, taking something that the idea would be that if you're an expert model builder, that you'd be able to take some vague idea that we talk about in a meeting, or some idea no one really has any idea of how to model, and turn it into a model. You would take the most important aspects of it, abstract those away from the problem, and then implement some sort of computational model, or it could be a biological model, but we really do mostly computation right now. That's what our resources sort of afford us to do. And, set it up, get the model running, show your results, do a demo on a weekly basis. That's sort of the goal for a model builder. Now, I don't expect people to come in being able to do that right away. The point here is to learn how to do that. So if you're interested in doing that, or if you know someone who is, then this is a great opportunity for them to get sort of engaged with that process. I think once we have someone who's really interested, we can move forward on this. We can sort of give them tasks to do. I can give them tasks to do where, we kind of do this gradually, step by step. We go from, sort of assigning them maybe a pet problem which they can work on, something that is, you'll be thinking about long term, and then attending meetings and looking through the Slack and seeing what kinds of problems people are putting out there, and then maybe modeling some of these. And then we'd critique the models, by just saying, is this something that's appropriate, And I think in some of the last few examples I've talked about with respect to AI ethics, or respect to Ashby's model of augmented intelligence, that you can think of models in a way, you can come up with a good solution to a problem. You can say, here's a problem, here's a model. It's a simple model. It doesn't take a lot of computational resources, but it's also very informative. How would we measure it? Come up with the measures, and then think about how it can be improved, or maybe your biases that you're putting into the model. So, the idea of using certain parameters. Why do we use those parameters? What do they look like? What's the mathematics behind them? Is it the appropriate model for this, or do we need to think of a different type of parameter and come up with a mathematical formulation for it. How do they relate to one another? And these sorts of things. So those are all the skills you would build as a model or acquire as a model builder. And you'd be working with a range of models where our interests are in they're very broad. So it could be anything from feedback models, cybernetic models, to networks, to agent-based models, and the like. So we have all these different types of models you can work with. Reinforcement learning is another area that we're interested in. So I think it'll jumpstart a lot of interesting avenues of research. And we have people in the lab who are interested in a lot of different types of models as well. So that would allow you to collaborate with them and talk with them about things. So it's that's one avenue here. Another avenue is to look at, to be sort of I don't want to call it information manager, but Jesse started in the lab, and I kind of gave him the role of lab manager, and he's taken to it quite well. So we have this lab management function, or this administrative function. Now, I know that's mind-numbing to some people, and maybe it's very interesting to other people. But what I want to do here is I want to create, I want to be a little bit more broad about it. I don't want to, eat your time up with administrative tasks. We don't really have, you're not going to get any sort of formal stipend for this. But this is largely, if we do come across the opportunity to get funding for this, it would be great. But I don't want to burden people with something. Because I know a lot of, younger people, they want to get research experience or, learn something. So I don't want to, administrative tasks are not, you can learn those things, but they're not maybe the primary objective. So I want to make it more like an information manager rather than a traditional lab manager position where you're managing information. So you're managing, for example, models or open data or something like that. Or I know Jesse works with Notion. There he is. Hello, Jesse. And so that's the idea of this information manager position. So it would be something like that. Well, right on cue.
Yeah, you could say that. Oh my god. Hi, I'm sorry for being so late.
It's okay.
Things occurred regarding technology this morning that this was involved. Are you sharing your screen? Because I don't quite see it.
No, I'm not sharing right now.
Okay.
I was just talking about the different roles in the lab. I was talking about model builder, and then I was talking about the lab manager, but I said that maybe there's an information manager. Maybe to think about it that way instead.
Nice.
So, I won't ask how, I guess you can tell me how you're doing, but I think, I get the point that you're...
Yeah, I'll let you finish whatever you're talking about, and then I'll say them.
Okay, yeah, I think I'm done. I think the idea here is that we're looking for people with defined roles in the lab. Those are two examples, but we have others that we can come up with. If you think of a role for yourself and you want to propose it, which is kind of an odd way to do it, but if that's something you want to do, then that's fine too. And we can work on how that fits into things. Yeah. So Jesse, you can give us an update, or I know you were working this week on a number of things. So.
Yes. Just in a bulleted point view, I've been trying to flesh out some of these roles and interests, roles and interests and descriptions, and I don't. I'm not able to show anything about that in the immediate moment, but I might send some things to you about that later today, just to kind of go over them. And I'd love to start posting them soon, but I haven't really done anything with them. I want to finalize some of this stuff basically. So that's one thing. I spent a lot of time this week at the IEEE conference, COINS, and it was, that's the conference on omnilayer intelligent systems. And another way of, like, what that really is in this case was Internet of Things, 5G related stuff, connected devices, a little bit about wearables and how they all relate, a little bit about, there were a bit amount of talk about blockchain and security. There's talk about, you know, some specific machine learning behind what enables a lot of these networking stuff. There's an extensive talk about IPv6, about 5G and 6G and 7G, and about how connectivity in devices is shaping the future of technology development and so on. And I don't know where we are in agenda about things, but I could potentially talk more about that a little bit later. Some highlights. I don't have a whole lot to say about it necessarily, but it came up. It's related to. I'm going to pull a bracket, say another group that I'm working with that was interested in that conference as well.
Yeah.
And there's a lot of interesting overlap, and also there wasn't anything explicitly about. Well, maybe there was, but very little bit. But there wasn't anything explicitly about AR, VR stuff to it. But it was, it is quite adjacent to that, and my stated interest in those things. So there's the lab stuff, there's the conference stuff, and as far as personal stuff goes, another week in Boston. Honestly, it was quite a long week for me, and it was just a lot of stuff happened that nothing like news breaking. There was a very full week. Probably the funnest and most exciting part of things is, and I mentioned this to Valley before, but it's like. That I was accepted into the inaugural cohort of the fellowship for, it's through the National Science Foundation, but it's called CS for Grad. It's the acronym for it, but it's the Computer Information Science and Engineering fellowship through the National Science Foundation. Computing Research Association.
Yeah.
Right? And I basically there's sort of an extended period of mentoring, and we get about applying to graduate school, and specifically applying to PhD programs in related to computer science. Or information science, basically. And with that, there's I found the information about that part of the second part of it. Like there's sort of two different aspects. One is the ongoing mentoring process, like graduate school, which extends all the way into becoming a first-year graduate student if you get accepted. And then if you do get accepted to a PhD program, you get a pretty good amount of funding. Right. So basically, I'm currently a NFF and COA fellow, which is pretty cool. And as I mentioned at the last meeting, I didn't like go into details about what a whore was, but one of the major things that I'm going to be focusing on, and this isn't required, but it's quite adjacent to it, is accessibility and outreach. One of the evaluations for
fellowship is that you have to show demonstrable U.S. commitment to wanting to be a PhD student as a base. There's no business to give it to, like alternate. There's no master's, there's no other education. You're getting a PhD with this fellowship, which is what I want to do. Absolutely. But a major evaluation for this, and I would like to go over this with Bradley sometime, just to kind of show, just to sort of show it, but it's, I guess merit-based in the sense of one of the evaluating such criteria is, are you actively engaged in accessibility and inclusivity and bringing people on board, and then expanding and opportunities for a variety of people, including non-traditional people and minorities, or people who didn't have this particular path. And in a way, it's kind of funny because when I was first founded about this fellowship, I was like, oh, yes, I kind of laughed at the other folks than me. I thought people were going to get this thing. But I did, and a lot of the work, a really big shout out to Thoery for opportunities here as a lab, and a lot of people that I worked with actually at NeuroSim that graduated from, because they of my now. They too, and many people are very active about creating opportunities along the lines of what I was saying, and I happen to really like them and be a part of a lot of things, including the New York Celebrate Company that were major part launches for and put together a lot of things, and I've been at for 3 years in a row, and being able to say that if you can employ that the last and the different kind of views with it's so much so it's not there's no form of
Jesse, I'm having trouble hearing you. It's cutting out. Yeah, the voice is not picking up very well.
Is this any better?
Yeah, that's better.
That's funny. In long story short, I want to really use the platform of the fellowship to encourage a lot of what's promoted and a lot of what's happened for me to get it, because that's sort of I'm really curious because I think this is the inaugural class. This is the first ever cohort of this, and I'm curious what we can do with it, in the sense of making it more popular and more accessible itself, and using the platform to further what using it to further its intended purpose directly, both directly by being someone who goes to school. I'm, among other things, let's say a non-traditional student with my background, but also continuing to promote a lot of the things. And the lab's been a part of that, not just in the specifics that I mentioned about involvement in the ethics team and the celebratory women in computing, but also I would even venture the open science and a lot of the efforts to be, let's say, to lessen the barriers to access and entry and involvement. And I think the lab should take a bit of pride in that, and the fact that you know, the NSF and other people are valuing that. So yeah, that's kind of what I've been dealing with this week among life stuff. And settling into Boston, it's moving in a new city, and people, and you know, time to eat and time to do stuff is a lot. But yeah. So one more thing about the fellowship. The next part of it, and I don't think it will affect Nanny directly, but there'll be a series of individual and group mentoring sessions for the next few months, which I look forward to quite a bit. And they start in about a week or two. That'll be, I think it'll be a lot of fun. And to be fair, like, some of the sessions look like kudos to Neuromatch, as a side note. If you've ever attended Neuromatch conferences or the summer schools, the academy stuff, a lot of what they're doing there is reflected in some of the efforts of this grant too, like how they talk about professional development and accessibility and things like that. So a lot of great conferences and big conferences are doing things that fit with the fellowship itself. And there's a nice bit of overlap between, I don't know, like in a way, I'm not just sort of like, oh, you know, this lovely fellowship isn't that nice, but also like I'm legitimately pleased to see government and academia, and even to an extent industry, being focused on some important stuff with these efforts. And I think having more people out there, I think this cohort and this fellowship will lend a little bit more credibility to it also, rather than just kind of being hand-waving and nice. It's sort of a, I like the impact that it's having and how it's reflected in some efforts. Because, like, you know, if this came in one of the graduate school panels that I talked about, or that I attended and talked about in the lab earlier this year or last year, but how, you know, showing that you're working on open data related projects, showing that you're working on open science, and that you're doing inclusivity stuff. Like, those aren't just sort of, you know, people have said that, you know, oh, it's important to do that. But having a fellowship that's oriented around that, maybe not oriented, but that notably, I think it was really cool to see the grades and how things were graded and why. And I just feel like it's good to see that movement having more than just some, like, there's more than words. It's some actual, hey, you want to do PhD research? You've been showing this? Great. Well, we're going to help you do that, and we're going to throw some money at you because we value that, and that's a good thing. And that's just quite a simple way to put it. But I've immediated, even before this happened, I reached out to many people in my past university, and this is a very interesting summer for me in general, but also it makes a really big deal, just for a concrete thing. It makes quite a big deal knowing that if you're a non-traditional, like if I could go back in time and tell myself, hey, there's a program that you could apply to that fits your criteria and fits the values you're doing and shows what you're doing, as someone who's on the cusp, like these are really important things for people who are on the cusp of really caring and potentially thinking about, hey, I like research, but is there a future in it for me? Can I do it? Am I going to have opportunities in it? If you're not from a background that has it, if you're not from a lot of confidence in it, and you're not from, you know, it. I personally feel there's a huge amount of research potential that's just needs a bit of a nudge and a platform and a space to do it. And I think that this lab is a great space for that, obviously. But also just knowing as a student, and this is why I kind of have been able to be in dialogue with a lot of the people who, you know, I have a center for undergraduate research at UAlbany, where I went to school, and one of the people there, Casey, is an amazing person, and you know, they helped me. I didn't qualify for a lot of things because of my background and the choices that I made in going back to school and being a non-traditional student. There were quite a bit of scholarships and grants that I did not qualify for. And I think just by nature, that had nothing to do with anything I was doing in school in the last several years. And it's quite a difficult situation when you put in that spot, because you're like very, very caught. Because it's like, geez, what am I wasting my time by pursuing this? If you're automatically disqualified for a lot of things. So I think being able to say, hey, you can, the National Science Foundation is looking for people who want to dedicate themselves to research and to a lot of important things, and some inclusivity, and some, you know, if you do that, there's stuff that says you can, regardless of a lot of factors, if you graduate with your degree and put effort into what matters to you, that's what matters. You can get rewarded for that. You can get some actual real world benefit from that, as opposed to just being, you know, hey, wouldn't it be nice? You can say no. It's a very strong confirmation, and academia is, you know, very weird about its validation as it is, but I think this is a nice. I see this really targeted, aptly, and directed at a very specific issue in academia, and a huge barrier for those to get to PhD programs. And I'm impressed that I really like what it is, and I'm sharing that with as many people as I can. I basically see myself as kind of an ambassador because of that. And so with that, there's a platform that I want to use to promote all of the good things about it, and to get people excited about research and doing that. I think it's really important for the future. So that's my impromptu soapbox about it, and my TED talk about it, and my promotion of it. And I'll say more about it later, but the short version is, you know, it's a very good thing, and I'm happy to be. It's great to be a part of it myself, obviously, and it's going to help for my graduate school in my future. But the program is good.
Right. Yeah, that's great. I think that's wonderful that you've got this opportunity, and we should talk more about the how we, you know, this can be all leveraged in different ways. I don't know the exact details. I mean, I would have like some advice on how to do things. You know, is it like maybe there's like an outreach component, or maybe there's like a, you know, sort of like getting people involved? I'm trying to think of a way to kind of do what you've said, but do it in a way that's not, you know, when you don't have a physical institution, or maybe more appropriately, you know, when you're trying to do something that's not really well established, how do you get it off the ground? And, you know, one of those things maybe is to get people, like, you know, create what like kind of what we've done with this group is like create an environment where people can come and start to engage with research and kind of move that forward a little bit more, because this group has been kind of organic in its creation. I think we started with a group that was a group of people who applied to a Google Summer of Code project, and then just kind of built from there. We built it into this group where we talk about all different topics, but it's sort of focused on the whole NeuroSim concept. So, maybe that's a way to, maybe if we kind of really kind of push on sort of that door, maybe there's a lot more we can do with this kind of format where we have, a way for people to sort of congregate or interact with content, or, get involved with research, basically very simple tasks that they can do. They don't have to be like in a building to do it, in a certain building to do it. They don't necessarily have to have a really high barrier to entry to do it. Those sorts of things.
Yeah. And I think that's kind of been almost like, that's never been a directly, like, even as lab manager, there's never been, well, actually, if anything, I might have like implied or written that a bit in like the professional development aspect of the lab manager description that I made a long time ago. But like, there's never really been a written doctrine of like, hey, you must provide this experience in the lab.
Yeah.
But at the same time, that's what has happened, and I think that's actually really important, and that's why I'm not just like saying a bunch of random nice things here, but like what this, I really hope that some of the lab's efforts for access and efforts to create these on-ramps, basically is what I see them as. These are on-ramps into, various stages of careers in research. And maybe even not everybody wants to do a PhD, but just, I think there's I kind of see it as a platform, as almost like a lifestyle or a life path that involves research, and you don't have to do it through a PhD program, and even to an extent, how I got the fellowship is like, I'm not in a PhD program, believe it or not, I am not in a PhD program, and I haven't been since I graduated, but I've been doing research for a long time, both in when I went back to school and after it. I've been doing a lot of different, and I haven't been doing hardcore wet lab work in a neuroscience lab or in a tech lab, but what I'm doing has been, had value in a research environment. And I think for people even just to see that, like it's so, I think there's even sort of, not necessarily stigmas, but a lot of presuppositions and expectations about, oh, well, I'm not, I'm not using a pipette, so I'm not really doing lab work, or I'm, in a computer sense, you're not doing the most in-depth parts of a model building or creating neural networks even. There's still things that you can do to get there, and there's sort of this particular barrier. I'm actually pretty lucky because I made it in a way, not to talk about how great I am any more than I already do, but look, I'm very fortunate that when I did go back to school, I went to a place that was extremely in favor of, had a lot of really good opportunities for, even in a state school sense, undergraduate research. And undergraduate research, in a lot of places, and a lot like I'll just say MIT because I'm very familiar with MIT, but there's this tremendous effort and emphasis put on your undergraduate research opportunities, your ops, and these things that you're supposed to do there, and all this stuff is just being like, oh, that's what you do. There's no questions asked about it. You were there to do that, and for people who didn't have that experience, being able to go to institutions that support that and kind of give those on ramps and those seeds of inspiration and opportunities is great. And then, up spaces like this lab help you further that and to show other people, in this case, the fellowship, is like, hey, are you continuing to do this? And that's great. And it's different. I would even say it's different than, like, because I now have a job in research that's in the industry, and I would say it's even quite different than having a research and industry-based job too, because having spaces where you could get the like Rowdy just said, you get these experiences that are almost research adjacent, or like proto research stuff that you can do, and sometimes it's hard to say, like, oh, what's the value of this and why are you doing this? But I think what I would like to use my platform to speak for is that there is value for it, not just, hey, you get this grant, you get this fellowship, okay, or the grant that both Avery and I got this summer, is quite related to that as well, actually. But not only is that part of it, I kind of lost my train of thought actually, but the point I'm making is these things are important, and I think the message succinctly is research is accessible to you if you want to do it, and if you find the right ways to do it, and you find some good spaces to do it, and you make effort to do it, and you have a community around you that supports, because it's very much, you need mentoring, you need to learn how it works and to make choices in industry, in academia, and outside of both of those things. There's different spaces, and it requires mentoring and community, but the message is and has been in my case here the last number of years, and now I have a fellowship that says that community exists and you can be part of it if you want to. So I think that's a powerful and a very good thing for people and the future in general.
Yeah, well, that's good. And I think that, like, some of these things, I'm going to write them. Maybe it would be good if we could create, like, either a document or some sort of presentation, set of slides that have some of these ideas in it. And the reason to do that is to get them fixed in our heads about, what our goals are going forward. Like, I know that for the fellowship, you probably want to be more organized in your efforts. And so if we have that thing there, we can, like, always go back and consult it and say, this is kind of what we want to do.
And I wanted to ask you about that, because this is often used said in a derogatory way, but I'm dragging Orthogonal Research Education Lab name through, not the mud perhaps, but through this conversation. And we haven't really talked about that. I mean, we have in private and stuff, but like, I would like to formalize that with a lab, because I'm in a situation now where, like, I haven't made any major updates, but I'm really having to brand some of my online content in this sense as, like, if what I said is true, you don't have to. There's nothing in the, just to be clear, there's nothing in the fellowship that's mandating I preach about anything.
Right.
But at the same time, I personally feel that if I didn't talk about it at all, that would kind of be doing it to serve. It would be quite incongruent with what's going on. Right. So I am I'm updating for lack of a better term, branding and messaging that I'm doing with my own website and opportunities that I'm trying to create and do. And yeah, like, I've been wondering, like, what's the best way to do that with the lab? Because, like, both, yes, it's cool. Hey, you know, you have a pretty good NSF grant, NSF fellowship that's associated with the lab now. Great, but like a lot of the things the discussion, let's say, that just took place about that, which is mostly me talking about it, but the discussion that we've had for a long time outside of this moment as well, that's, I don't know if that's been formalized and put into something for the website before, or for the lab on the website somewhere before. And I obviously am happy to kind of sort out what that should be, because a lot of the points and values that I'm talking about are, you know, these are my words right now, but I'm just sort of regurgitating and remixing what has happened literally in my 2 years here with the lab, you know. So I don't know what we I don't know what you'd envision for that, but I'd be happy to do it and make it a thing.
Yeah, so I think, yeah, you're welcome and encouraged to use like the logo, like for Cognition Futures, for example, to have like a website where you have the tie-in to the lab, and you know, make sure people know it's like part of the lab, and you know, it's a way, because what I've done with some of these, I've basically created a bunch of different websites for different projects. So it's like there's a main website, but then there are different sub-projects that have their own web presence, and the reason for that is I want to kind of make them modular and, you know, push them kind of away from one another, but also to bring them together when appropriate. So, and that's
go ahead.
Oh, and then I guess the other thing is that, yeah, I think there's some strategizing in terms of how to. I agree that, you know, I'm happy that you're able to get out there and sort of do a lot of the, you know, branding work and PR work that needs to be done for that, to raise awareness of what we're doing, and that's great. You know, I don't know if we need to be more strategic about it. Probably, I mean, that's always helpful, but I think that's good that, you know, you're getting out there, and I think more stuff like this where we're kind of like, you know, we have a public-facing sort of research opportunities for people. You know, maybe that's something I approve of. So it's not a problem. And I don't know what else. Right now, I'm thinking about like some of the things that I think there's a lot here to kind of go over, and I like the direction that this conversation is going, because it's kind of bringing together a lot of the things that I've been kind of thinking about in the back of my head, but I haven't really wanted to try to pursue. But now I think maybe we can pursue them a little bit more.
Yeah, and even like absolutely 100% to what was just said, and kind of zooming out, well, in the lab sense, and thinking as a lab manager, I'm working on a kind of probably Notion based, but kind of like a site map of sorts, something that's a little bit more coherent that can tie into this sort of thing. I think that would be helpful. And there's, it's not that it's not there, but I think a particular way of visualizing it and arranging it would be good, because you could, like, I have this sort of image of a layout of, like, in the most classical sense of a site map, but also having something like, you know, you list the different projects there, MetaBrains or Cognition Futures or whatever, but also listing some maybe not necessarily a mission and vision kind of a thing, but a listing, a document that like there could be a web page or a website or something dedicated to what the conversation that we just had, the discussion that we just had about, you know, orthogonal and inclusivity and opportunity and outreach, because that has been that's kind of stated in some of the materials that I saw about like open science and all that. But there's also just, you know, there's some very explicit stuff that could be stated and written and communicated to people that would be, you know, beneficial for them to read or know. If you go to, you know, if you find us, you know, you could easily see all the related material and value it. So.
Yeah. Oh yeah, I agree with that totally. In fact, I haven't done that, and maybe I should have done that a long time ago. But to have like a explicit set of like a web page, maybe for inclusivity and opportunity, sort of how do you, you know, if you're looking to maybe do research. I mean, you know, the lab isn't for everyone. But that being said, it's still inclusive because, you know, it's not going to give everyone the opportunities they want. Maybe they want to have like, you know, an elite research opportunity where they're going, you know, doing research at MIT. But then a lot of people, you know, they need to have some sort of experience that's maybe more tailored to their needs. Maybe they're a non-traditional student. Maybe so those things, you know, we're going to highlight those things. Say this is if you're in this category or this is what you're sort of looking for, and then we have some opportunities for you.
Yeah, and like the one of the biggest selling points, for lack of a better term, for the lab is number one. Well, we just talked about inclusivity and openness, yes, and no, the lab isn't. This isn't the same as, you know, this is almost the opposite of a really highly a lot of research, and both in industry and especially in academia, you are funded. And this is akin to a conversation that Bradley and I had recently about startups and how startups are funded. But a lot of funding around research or new idea creation in general is very intentionally or not, often sometimes it is for good reasons, as soon as it isn't reasons or not for good reasons. But it's very much siloed and constrained and quite bridled to very specific things. And that's not saying I'm not saying it's a bad thing. It's just having the opposite space of, you know, we have access to funding, but we're not motivated by funding here. And what that affords in a very unique way compared to every other situation I've been in, honestly, outside of like some generic open source projects that are collectives of people working on stuff, yeah. But it's a really unique situation where, in addition to the accessibility that we've mentioned, there's a really, you can get research kinds of experience here that are really difficult to get elsewhere, and specifically, you know, specifically these sort of intermediate level skills and sometimes very beginner skills, but these sort of foundational and growth oriented experiences that are, you know, kind of getting your feet wet and exposure. You can talk about NeuroIPS, you know, which we do, or you can talk about, you know, the Philosopher's Web Cafe, which is sort of someone's, you know, passion project academically that brought together a lot of things. That's a reference to Charlotte's. The work we did in December, you know, 10 months ago or so now. Or you can, you know, you can talk about these experiences, or you can, after you do enough, and what I particularly benefited from is, like, you can lead a project and get experience managing a project, and that's huge. I could go on at length saying, my sense of research and project management and leadership. And again, going back to the fellowship directly for a moment, like if you I have a I just noticed like a I think I have like got like a spider bite in my ankle.
Oh.
It's itchy. I was like, what is that? Anyway, if you have a that was distracted. But the point being, if you get to a place where you're running your own project, it's very much if you have a desire to be a PhD student or researcher, everybody who gets a PhD obviously doesn't become a professor, or you have to do research in quotes or directly, once you get that. But a large part of a large part of these programs are like, are we going to continue to build a pipeline of research in this case, this is the government saying, hey, we want a pipeline of researchers who, for all the people who, maybe have an indirect path but still want to do research and contribute to the research effort overall in the country, particularly in critical fields like computer science, engineering, information science, and so on. Hey, you got this, support for that. And so, in thinking about that, and it comes to what we're saying, being able to go from, hey, I want to review some papers in the lab today, to, after you spend time here, I don't think it'd be overstated how significant it is to get experience in leading research projects as early as you can, and with people who want to do it, and knowing how to both do that. And obviously, I haven't had the most epic things to say and write about in that sense, but I have done it. I know what it's like to do that, and I feel like that's really invaluable. And that's not something that you can. That's not really easy to get into in some ways in aspects of both academia and industry. So having a space that's relative to that, but maybe adjacent, and with a lot of the, there's a lot of importance to having there's like a full stack element to it. Like you can go from the bottom up to the top into how it works. You can get inside and outside experience as being part of a project and leading projects, and it's not you can get a lot of the skills related to a research career and a research life and a research oriented outlook through this in ways that are very complementary to a lot of other established and less mobile. And that's sort of the trade-off in general. There's very clear benefits and trade-offs, but there's clear benefits to how the lab is set up and why it exists. And I think I'm not trying to be overly ingratiating about that, but yes. There are very important reasons for why the lab or spaces like this exist and what they can do, and they need to be promoted and celebrated for that.
Yeah, I think that's great. Yeah. So let's follow up on this over the next week and coming weeks. So why don't we move on though to a couple other things that we had. Thank you for that discussion on this, and I think this was valuable because it kind of gives us a good way to view a lot of this stuff and think about it and move forward on it. Okay, so let me share my screen here. And if you're watching on YouTube, you're welcome to give us feedback on these ideas. I know we have a couple of channels here that we want to maybe have this discussion in. Some of these are private to Jesse and I, and if you want to join those channels, you can request to join. You could also maybe ask in research questions or open chat forums. So actually, let me check some of these other channels. The MetaBrain channel doesn't have anything in it. I think the open chat forum has a couple things. Okay, so this was from this past week. So we had, I think this was during the IEEE COINS discussion that Jesse was involved. Actually, yeah. So Monday, quite interesting stuff at IEEE COINS. And so some of this is in the open chat forum section. Ethics Society Tech, it was quite interesting and fits with the CogSci stuff. I'm thinking ahead. So this was unrelated to the conference, actually. He saw someone talking about embodiment in therapy, race/ethics, and how to convey affect and other embodied experiences. So this is something that he saw was independent of the COINS conference. And then there was this talk on federated learning at the COINS conference, and something as a means to modify smart wearables and data collection. And then I guess you might have some notes, Jesse, on some of this forthcoming.
Yeah, I've kind of putting together a program of, not a program, but like a review of the conference. I don't, let me see if this American can quickly show for that.
Okay, let me.
Yeah, where did this go? I'll just this won't take hardly anything.
Right.
I think you can see my screen now.
Yeah.
But yeah, it was this week. Here's the main page for it. Just coinsconf.com. It was very interesting and had a couple different sets of. This is quite zoomed in actually. Looks a little more normal now. Yeah. Interesting. I'll just quickly show the program, but basically there was 3 different sessions of you had your speakers and you had your sort of topical areas of IoT, sensors and system sensors, e-health, big data, security, smart cities and blockchain and security, and there's I didn't get to go to all of the keynotes, but one of my takeaway messages from these things are the interrelation between there's a large shift between having really segregated devices and a centralized network, and moving towards and this is I think Professor Levide is one of the ones that work for this, and this is kind of a theme everywhere, but just the way that like super IoT and next generation wireless. I think one of their topics was basically that between that and the massive federated intelligent reality. It's just these two are and kind of maybe most directly related to the lab in terms of about conceptually. Just a sense of how much there is a movement away from. There's a very strong movement away from really disparate like sensors that are very far removed from each other and don't communicate with each other, and only communicate through. Have to go back to a main server, a main node. You go all the way back to the network and communicate there, and you go back out. Like a very. It's going from. It's a bit like, you know, sort of like conceptually like more advanced. Kind of like an organism evolving and having more complicated system overall. Like you're going from, okay, here's a very simple feedback with inputs. Here's where the inputs come in and go back to this main central hub for processing, and you go out. And it's coming to much more just how the devices and then all the next gen devices and so on, and super IoT, or the world of things, the web of things. It's becoming much more just, you know, you're going to have these really high capacity devices that are much more distributed and much less centralized. And how are they going to communicate? And how do they affect things? Like, you're not going to have a massive amount of computing power, you know. The way computing power and accessibility is evolving is there's going to be a lot more power in excuse me, in some of the devices that we have, but then it kind of is kind of interesting where it's kind of going with the federated learning or federated reality stuff. Is like there's a really interesting situation where you're having extremely powerful devices that can do a lot of computing in them, rather than having to go back to a server per se or some other thing. Or you can do it device specific. But a lot of the federated reality stuff is integrating these different streams of input and ways to optimize that, given what we have now and where things are going forward. Because a lot of Wu Chang's talk, I think he's Dr. Wu Chang, and this with the MIST. It doesn't quite say. It's a professor, but yeah. What sort of how, well, given these disparities and these you know, there are ways to optimize the data we are collecting, and then how do we efficiently interpret necessary data given all these sorts of different sensors and inputs and flows, and how do we integrate these things, and that's a really exciting, very exciting field, because you can get data from a variety of sensors, like if you're monitoring a healthcare patient, if you're monitoring a factory or a system, an industrial system or a farm or a setup, and you can have a number of different flows and kinds of information, and what both, you know, federated reality efforts in general, or just it's sort of like an advanced multimodal integration of information streams, kind of sync, like, you know, and then they go and there's specific pieces about like systems on a chip, networks on a chip, ML on a chip, but leveraging these things with intelligent reality, which is sort of, you know, kind of AR VR related stuff. Mm-hmm. It's sort of, and this is what I would highlight for the lab, and some of the things I've been saying, like regarding like AR VR kind of stuff, and it shows us a little bit in the presentations, and I don't have good slides to show right now for it. That's the thing too, like some of the material, I think they kind of are reneging, or like some of them maybe can't share as much as they wanted to. So I have some like personal copies of stuff, but I don't know how much it would be public. But what's really quite interesting in this sense is they're examples of almost like virtual or semi-virtual environments where you're creating a kind of it's almost like a pocket like if you're familiar, if you're nerdy enough to know like something's in D&D or some science fiction things, it's sort of like creating a pocket dimension. Like in this space, it's this artificial space where you can sort of like, you know, it's sort of like there's some sci-fi movies, you know, where they just like pull this variety of things, like, oh, I want to see this day on the screen, this day on the screen, but like actually doing that in a federated, in a combined reality where you're just able to channel and visualize and display and monitor a lot of streams of information in real time, and it's almost like conceptually speaking, it's quite akin to, and they didn't talk about it this way, but just in terms of cognitive modeling that we do in the lab, it's sort of like creating a brand new suite or user interface that combines many different computations and displays of information at one time, and being able to make decisions based off of that, or having a very different view that has otherwise been inaccessible or greatly. And a lot of what his work has been is like, if not necessarily new, but just ways of tailoring the processing, being able to really heavily select for what you want to see, and then having both the technology and capacity to filter that, and then display it in new ways that will like rapidly facilitate quicker and better decision making about it. Let's see. Yeah. Effectively manage fast and multifaceted settings via heterogeneous smart devices within immersive space. So it's sort of like, in this particular case, what I was kind of talking about a bigger picture, but it's just really interesting in a concrete sense. It's just about, hey, there's a lot of really cool devices out there that are getting better, getting much more capabilities, and with the devices themselves, especially in combination with what this is getting at here about the empowerment of these devices, and how Internet of Things is not just going to be, hey, you have a smart, microwave now, but just the how intelligent those systems can be on their own, and they can talk to devices will be able to just have much more in-depth conversations, not necessarily with a language as we say it, but what they can communicate to each other, rather than having to go through a centralized location or being passed through a lot of other barriers. Between that and the federated reality combination of these things, that we, there's sort of a twofold thing of the devices can do a lot more, and if we were able to visualize it, what that looks like and how that's happening, that's just a very very cool stuff, and I think what's coming from these specific areas and how the advent of 5G and 6G are coming along, and also even just to note that one interesting thing to note is America isn't at the forefront of a lot of 5G and 6G adaptation, and I think that's something to keep in mind for the future and some of the developments that are happening. Like there's an interesting set of ideas that lead to how like in countries in Africa, there's sort of this push to just leapfrog technology, leapfrog. You don't have to build wires. You could just have a lot of cell phone data, or there's a lot of projects out there about wireless satellite-based internet. Like there's Swarm.space and things like Elon Musk companies about that, and the relation between those, and a lot of other ideas. Like Amazon is in space, and a lot of tech companies are in space trying to enhance internet connectivity that can facilitate this outside of 5G or 6G kind of stuff. And it's like, there's there's an interesting, for lack of better terms, race about implementation for this, and who's going to be able to develop things that are going to leverage the actual, like, tremendously powerful stuff that's coming along as we get towards 6 and 7G. You know, like this is down the road, but it's also not. It. I think we're really on the cusp of seeing how much the ability to powerfully transmit a lot of data and then being able to create a lot of new, very new combined data interpretations for ourselves, like the devices on one end, and then creating these very new views for these really powerful, varied, and very specific points of integration that are visualized and understood in new ways. And this is quite a space to be thinking about and something to be aware of as we look into what's ahead in that sense. There's a lot of interesting stuff about hardware talk discussions. A lot of talk about blockchains. I don't really have a lot to take away from that. International computing. This is a very good talk that I don't think I got to. And then a lot of the papers, which I don't want to get into. That's all I wanted to share with that.
Okay.
I'll put some. I'll put together some more material with that later. But I really want to highlight those two talks in specific because I think they're really, frankly, important for everybody who's electrical getting into anything about networking or sort of communications or just understanding what that space is going to be like. As people working remotely in the future, just kind of a heads up about that was quite insightful. And then also, I think there's some, augmented reality, federated reality ties to what we've been alluding to for a while anyway. But it was a good conference.
Yeah, thank you for that overview. And, maybe if you could prepare a little bit of, just kind of a document with some of the screenshots, and that would be good just for archival purposes. But that was a very good presentation on a lot of that. I'm really excited about this federated reality idea because I've been thinking about some of these, how we can do, virtual reality without being gimmicky or having a lot of overhead in terms of technology. And so that's something I've been thinking about in the back of my head. And I think, maybe we should have some more discussions about some of these, things like this, or maybe some, more, I'd actually like to build sort of a demonstration, how, maybe you can simulate things with respect to people's perceptual systems, or little demos that sort of leverage some of the features of artificial or of virtual reality and augmented reality. And I know I'm just kind of babbling here about this, but I'm I'm thinking about how we can fit into this space. And so
and it very, I don't want to linger here too long. I was kind of holy crap, it's much later than I realized. I'm sorry.
Yeah, no, that's okay.
Well, very quickly I'll say there's a what I was able, some of the demonstrations they showed about the federated reality was really interesting because it was sort of you could look at a normal setting or a factory setting, and then with a certain set of views, or I don't know if they were have glasses or whatever, but looking at machines, you could see real-time updates for how a machine or a component was working or what it was doing. So I think one of the coolest things about this would be what federated reality could let you do in some ways, and this is both in a general sense and a bit of a nod to how it could be useful for what we're talking about more specifically in the lab, is federated reality could offer really interesting toggling between levels of what you're looking at. Like you could very quickly go at how is this specific individual unit working in a machine, for example. How's the you know for some reason I want to say fax machine. How's the fax machine working? Which is like almost anachronistic at this point.
Yeah.
But you know, how's this computer working? You know, right? And then zooming out, well, how's the cluster? How's the whole? How you the ability to go from node to centralized unit and to see different flows of information through them, and to see them as you're physically walking around a space. Like that's quite interesting. And I think there's some sort of like inverted opportunities for that as, okay, well, what could an agent you could flip it so that the agent, like you're walking through a space that has an agent or a representation of an agent, and how is that agent, whether it's, I'm not saying it has to be like a human, like that's a whole other can of worms, or a human-like agent.
Yeah.
But just being able to examine a system of, an artificial, or otherwise a system at different levels, and to be able to, it's sort of like, this is not a very good analogy, if you get what I'm saying. It's a bit like removing the need for a microscope or a telescope about some things, and just making those processes with federated augmented reality, like just sort of expanding your a few clicks, or expanding minimizing or maximizing a screen kind of a feeling. And I think that's exciting and different and powerful. And I think back to all of some of our older conversations about 3D environments and agents in them, and so on and so forth. And what does this stuff imply for that? So I'll leave it at that.
Yeah.
For a short time. So.
Yeah, so it's like the viewpoint networks we've talked about in the past.
Yeah.
Yeah. Well, thank you for that. That's good. I'm going to share my screen. I'm going to go through a bunch of stuff here, and I'll probably take about 15 minutes over maybe. But I wanted to just get to these things before we go. So I had a crack here about federated learning being machine learning from the heart of the federation. Again, there's another one of our custom emojis in the Slack here. So this is this thing about foundation models, which was a session that was held at the Stanford AI. There's an organization at Stanford that does a lot of AI stuff, and they hosted a workshop on foundation models, and this is the preprint for this. I'm not going to get into the preprint, but it's if you're interested in large machine learning models, that's something that they've written a paper on. I just don't really understand what foundational learning is, or foundation models, but they talk about it more in the paper. And then, so that was open chat, and then I think that research questions had something, I don't remember which one it was. Oh, maybe it was still an open chat forum, but Zura asked a question here that was about, I'm interested in your personal opinions about this question. Do you think it feels something to be C. elegans? And I gave an answer here that was about how C. elegans has touch receptors and polysensory interneurons, which means that they can feel things and integrate things from the environment. But I don't know if they generate awareness because their connectome is very small, but we really don't understand how awareness is generated. So I think there's another, people in the singularity community seem to like OpenWorm. They have this idea that it's a path to the singularity, but it's hard to see how that could be the case. Nevertheless, I was talking about this, and I brought up this TV tropes link, and then Jesse was fascinated by it because it was why are you bringing up TV tropes here? But
I am a huge fan of TV tropes, and the fact that they came up in the lab without me putting them in the lab. Just I think that just, we should put, there should be a very formal and very academic and very professional looking reasons to be a part of the lab, and there should also be like a secret other hidden gem reasons for why you should be part of the lab, and this should be on it, I think. So.
Yeah, I think that's good. Yeah, so we do TV tropes in a semi-serious manner here. Okay, so I wanted to talk about some of the things coming up in the next week or two. As you'll recall, we have these two papers we're working on here. This this pragmatic CGS is we're I haven't really started on it, but it's due September 10th. It's like a 4-page paper, so that might happen. We'll see. But we have two things that are coming up more immediately. This MetaBrain Models paper, which is for this embodied intelligence ebook. This is due in a couple days at the end of the month. And then this paper for the artificial life special issue for the EI workshop as well. So they had two different things you could do. You could submit to the ebook, or you could submit to a special journal issue. And this special journal issue is due in September 18th. So this MetaBrain Models paper is almost completed. And I know, Jesse, you haven't really had a chance to look through it too much.
Yeah, I this week was a bit of a lot, but please send me both of those and the one later in a few weeks as well, and they will be worked on. Okay. I'll actually put things in the paper more so now. So.
Yeah, so I mean, at this point, we're kind of like, I just wanted to get, I want you to read through it and see where we are. If you see things that need, references that need to be added, add them, things that not necessarily just reference. I mean, I guess we could add references, but if there's something critical missing, that would be good to add. I've put in a lot of stuff. I put in a whole section on embodiment and, kind of based on our conversations. So, I mean, the paper is, I think it's okay. I mean, I want to make sure that it makes sense. So, if you could read through it, just make sure it makes sense. Where it doesn't make sense, add comments. And then add references if you think there's something we're missing. We have a lot of references, and we're kind of we're limited to 20 pages, and we're at about 18. So I think we're pretty close to being done here with the length. We have 6,300 words, and kind of goes through a lot of aspects of the MetaBrains. Earlier in the meeting before you showed up, I was talking about this question of layering and encasing. So this is something that is something that kind of came up in the course of doing this paper. It was a question of what does it mean? Why do biological systems have this layering? You see it in a lot of different contexts. What is the significance of it? Is it for information processing? Is it for are there for other things? And so there are going to be a lot of things that come out of this paper maybe that are interesting. But the paper itself, I think, is pretty good, and that'll be submitted. I think, the 31st, I think, Tuesday, correct?
I think so.
Yeah, so that'll be that. It has to be done by then. But then I think we'll have time to review. They'll probably peer review it, and then we'll get comments back. So I think, I think it's moving along. And again, this is stuff that I've done based on our conversations, so we have a lot of different things in here, but I think it's a pretty interesting paper. So that's imminent. And then for the ALife paper, I submitted this abstract. This is the full paper. This is the paper that we submitted to Artificial Life Conference. And I was thinking, we could just change it. We could make changes to it based on their comments and review, and then maybe some additional stuff. But I think what I'm going to do instead, in the interest of time, is just to submit this paper that we have been working on. We put this up on, this is the paper, sort of the original rationale for this group, this Saturday morning NeuroSim. And we were working on this paper in 2019, throughout 2019, late 2019. So this is something that was on the archive and generated some interest, but we never published it anywhere. So I think what we'll do is we'll submit this in lieu of the other continual embodied learning paper. And we'll submit this paper, and this has Stefan, this has Jesse, and this has myself, and we all presented at the workshop. So we can, we'll all sort of have a stake in this, and I think it'll be interesting. I think that'll be a better shot at it. It kind of weighs out a lot of this stuff. So this is pretty well done. I mean, we can just submit this without too many changes to it. Maybe like do some editing before we submit it, and then see what the reviewers think, and then there'll probably be some edits. Hopefully it's something they enjoy or they like, and I think it'll be I think it'll be a pretty nice paper for a special issue. So that's the plan on that. So again, we have these things due, and then we have the this pragmatic CGS paper. Maybe that'll happen. I still have to get it together, and I think I'll try to loop in Charlotte and Jesse and Avery on this as well in the next week or two, and see where that goes. So that's what we have in terms of deadlines, in terms of papers. Now I wanted to go and talk about some of these categories that we have papers on. I found this interesting. I've been talking about category theory off and on in our group, and I found this in doing research for the MetaBrains models paper. I found this interesting category theory of agents topical area. And so if you go into this folder, and I can share this with people, probably put it in the Slack, we have a number of different things that people thought about. So first of all, if you're interested in category theory, we have a few papers in here. There's a paper category theory for programmers, and a paper categories for the working mathematician. And this is by Saunders McLean. He was a early category theory person. And so if you're interested in category theory, those are good starting points. It's a very hard learning curve. So, maybe you do start there if you're interested. You can go through and maybe get some insights on what it is and what the questions are. It's pretty mathematically rigorous, so it's kind of hard to follow. You just don't worry about the symbols. Just kind of read what they're saying, and just kind of like try to pick up what you can. Don't worry about the I want to be accessible here. Don't worry about the symbols and about some of the jargon. Just kind of like go through it and a couple times and see if you can understand what they're doing. But then, even if you can't do that, I would encourage you to look at some of these other references. So this is Michael Arbib is AI researcher, actually. And he's I don't know how obscure he is, but 30 or 40 years ago, he was doing a lot of work with robotics and with AI and biologically inspired AI. And so if you go back and look at Michael Arbib's work, you'll find that he's done a lot of stuff on different things in that area. But one of the early things that he did was in category theory. And I found that interesting because I had heard of Michael Arbib and I'd read a lot of his work, but I didn't really realize that he was a category theorist before he became interested in AI. So there are a collection of his papers on category theory. There's this book, Arrow Structures and Functors. I don't know if you can get access to it, like as an ebook or something, but this is one of the books that that Michael Arbib and his co-author wrote in the 70s. And this is sort of, I think, maybe a computer science friendly take on it. I know it's an older book, but a lot of this stuff doesn't necessarily change. If you want a good, sort of basis of what it is, that's a good place to start. And then you have these other things. So there's a paper, Basic Concepts of Category Theory Applicable to Computation and Control. So in this case, Arbib is writing for an audience that is interested in cybernetics. And of course, this is an older paper from the 70s, but it does have this sort of cybernetics flavor to it. So you have sort of a definition of what category theory is with respect to, what you have to know, like these epimorphisms and monomorphisms, products and limits, functors and adjoints. So it just kind of goes into some of these jargon terms and how they're defined, and then kind of going into how this relates to control. And so it's pretty mathematically heavy, but I don't know, maybe you can get something out of it. And then this paper, Category Theoretic Approach to Systems in a Fuzzy World. So this was from 75. Maybe this is a little more accessible. This talks about like how the world is sort of vague and fuzzy. And again, we talked about the syllabus on computation and inequality, that course that's being taught at Berkeley. So that course, they talk about like fuzziness and vagueness as being maybe the flip side of modern computational computer science, where there's this precision that's required. And so, this talks about fuzzy worlds and how you can model that using category theory. So a lot of this stuff goes, is brought up in this paper, and this is the more accessible paper than the other one. They kind of go into how logic and mechanics are related and control theory, and then so this is relevant to robotics research, as well as artificial intelligence. And then there's this Automatica paper. This is from 1974. It says Foundations of Systems Theory, Decomposable Systems. So one of the things about category theory is that it's both compositional, which means you can take pieces and put them together, but then at the same time they're decomposable, so they can be decomposed into different parts. And so this is talking about like in the modern state variable period of control theory, three concepts have come to play a central role. Reachability, before seeking an optimal control, making sure the target state is reachable. Observability, making sure the outputs are rich enough to deduce, probably over some period of time. And then realization, to adequately control a system, one must be able to construct a sufficiently accurate model or realization of it. So this is their kind of way they're doing this, talking about category theory and decomposing a system. So again, this is fairly mathematically heavy, but it has maybe some nice diagrams and things like that. So you get a sense of what they're trying to do. So that's the category theory of agents. Let me get back here. Okay. All right. So that's anything to mention on that, Jesse? Or
not directly. I was reminded of something else I saw this week that's adjacent to it. But no, I appreciate. I will look at these resources for sure. I think. We talked about things you might want to cover this in the fall, and that definitely fits with that. So thank you for finding those things.
Yeah.
I don't know. You have more things you wanted to say, I think.
Yeah, just a couple more things here. Then there's this thing. I have a couple, and I'm not going to talk about this too much today, but we can come back to this. This is anti-racism and representation, and there have been two papers that have come out recently on this. So, last year there was a big push for, representation and anti-racist. So it was a very in vogue thing back then, and people have kind of maybe forgotten about it a bit as time went on. As people weren't as wasn't right in the front of their minds. But these papers kind of talk about following through on this, and following through on some of these things that people were talking about last year. So this paper is Anti-Racist Interventions to Transform Ecology, Evolution, and Conservation Biology Departments. And the idea is that we want to see through some of these programs to sort of increase representation, because oftentimes a lot of institutions will talk about it but not really implement any real meaningful changes. And so marginalization and oppression as a result of institutional and structural racism continue to create barriers for inclusion. And so, how do we overcome this? And many academic departments seek concrete ways to improve the climate and implement anti-racist policies in their teaching and research activities and training. So they present a toolkit of evidence-based interventions for academic departments to foster anti-racism in 3 areas: in the classroom, within research laboratories, and department-wide. So that's one paper. And then there was another paper that came out about the same time in Neuron. And this is kind of going back and looking over the past year. So like last summer, people were talking about this a lot, and then it kind of cooled off. And so the question is, are people following through on some of these things? And so our diversity, equity, and inclusion initiatives fixing systemic barriers. And then so that's basically the abstract. This article highlights progress thus far and emphasizes the systemic and cultural shifts needed to support and retain historically excluded scientists. So a lot of these, a lot of the DEI activities of departments, do they follow through on what they're saying? So they talk about funding opportunities, and there are specific funding opportunities targeted towards Black students and gay and lesbian students. And so those are, good for sort of continuing these efforts. You have other grassroots training-driven movements to demand change, to sort of find a path. And so we were talking about this earlier, and I think this is an interesting sort of way people are doing this in institutions. And, what kind of lessons can we learn from some of this? What are sort of, if you boiled it down to some principles for making things accessible, how would you go about doing this? How can you implement this, in a way that's, we don't, in this institution, we don't have a lot of barrier, like institutional inertia, but in academic departments, there is a lot of institutional inertia. But how do you implement these things so you can actually make a difference? And so they kind of pop through that in this paper. So that's, I wanted to bring, and we can come back to this in the following weeks. I don't know what people's thoughts are on that, or if they have other papers that they've seen where, maybe we can draw some more lessons from. So that's that. And then finally, I wanted to talk about this other set of papers, and this is kind of a shift again towards another topical area, but this goes back to when the CogSci conference was going on, and they were talking about evolution and neuroscience and how people have thought about like these 2 areas. And so in this case, this is specific to neuroanatomy and how people have thought about neuroanatomy. And it's interesting that, like, when you think about different fields, and this goes actually back to our trajectory stuff even, if you think about how different fields have evolved, you have like people doing work in, say, the 18th and 19th century, and they had certain ideas about the world, and some of those were, pre sort of Darwinian. So they didn't really think about evolution in the same way that we do today. So, the history of evolution is long, but before evolution, which means like Darwinian evolution, naturalists framed their thoughts on the assumption of a fixed scala naturae as conceived by Aristotle, which means that there was this idea that nature existed in this scale from primitive to, advanced, and that, all animals and all the elements in the world followed this trajectory. But the problem, of course, is that's wrong, that those things don't actually exist in nature, and it's certainly not the way to think about evolution. So this is the thing that influenced a lot of neuroanatomy as it was developing. And so people thought about neuroanatomy in this way, and it didn't necessarily change with, unless there was an explicit inclusion of Darwinian ideas. So, like a lot of the people, the father of comparative neuroanatomy, for example, was around in the 19th century. It kind of combined Charles Darwin's concept of evolution with the then current version of Aristotle's scala naturae. Edinger viewed evolution as progressive and linear, from fish to amphibians, reptiles, birds, then mammals, culminating in humans. Now, of course, if you look at a tree of life, you see that humans are this curious sub-branch of the tree of life, But in the scala naturae, humans are the ultimate expression of evolution, which, of course, we know is not really true. There are a lot of different branches of the tree of life. So, this is the sort of the idea that, you have these sort of underpinnings of different ideas that underpin your way of thinking in a certain field. So if you learn something in, say, like cognitive science or in neuroscience or neuroanatomy, sometimes these ideas are sort of underlying sort of the terminology and the way people think about problems. And so it's important to sort of deconstruct these. The supposed evidence of past lives in modern brain structures resonated with the law of recapitulation proposed by Serres and Saint-Hilaire and formulated by Ernst Haeckel in the aphorism ontology recapitulates phylogeny. So this idea actually has its roots in something that's pre-Darwinian. So it's interesting that, so this idea is kind of proven not to necessarily be the way things work. I mean, it's a nice aphorism, but it's not really mechanistic. And so this is the idea that more recent or advanced species pass through successive stages represented by adult forms of more primitive species. So this has been refuted at the level of embryogenesis and of brain evolution. And so the old ideas often are applied and then just kind of stick around in a field, and then we use them and don't think about their sort of utility. So this paper kind of goes through a lot of this. And then there's this other paper about the evolution of the nervous system, changing views of brain evolution. And this talks again about the scala naturae, which is inherent in a lot of the historical views of neuroanatomy. And, this applies to a lot of different fields, that there are a lot of these sorts of pieces of baggage lying around. And so, but just to bring it to neuroanatomy, you have this sort of view of the scala naturae, and it's kind of sticking around in the way that these things are thought about and conceived of. So this is something, if you're interested in the trajectory stuff or some other area similar to that, you don't have to be a neuroanatomist to appreciate what they're getting at in this. So I know that was a very fast overview of some of this stuff, but I think, do you have anything to say, Jesse, about any of that?
No, if we had more time, maybe next week we can follow up on it, but it's kind of a tangent, evolution, but there was a poll by Conrad Recording about evolution and deep learning and neuroscience stuff that kind of makes me think about that, and I think, so that was on my mind this week, and I appreciate seeing that stuff. That's good. We don't have much time. The only thing I would mention very quickly outside of that is, I'll share my screen quickly here. Can you see this?
Yeah. Yeah.
I listened a little bit by happenstance this week of we should talk a little more about the test of the day and AI stuff, I think maybe next week.
Yeah.
But I listened a little bit to this with Joshua Bach, who's an interesting and offbeat guy, and Lex Friedman has kind of opened up his talk about things. But this is a shout out to classical cybernetics for making, it was both explicitly and explicitly stated during kind of the first half hour of this whole talk. Bach is very pro models of cybernetics and models and agents and models, and a lot of talk about that. And Lex sometimes, I think he's intentionally not too familiar with stuff. But it was a very interesting concept of the way the discussion went was sort of there were major references to every good regulator theorem, even though it wasn't explicitly stated there, and just a lot of stuff it was like a modern day take on cybernetics, and people it was explicitly mentioned, but I think a lot of people would listen to the conversation and hear the word cybernetics a couple times, but not realize that almost the entire first half hour of the discussion is covered with a lot of very old cybernetics concepts. So I just wanted to mention that for this podcast episode 212 with Bach, and he's a cognitive scientist, and this talk about these like life and free will and simulations on base layer reality. Like this is all quite a bit of discussion about cybernetics. So check it out if you want. I'll leave it at that.
Okay.
And just kind of a surprise, like hey, that's something that we could use in the reimagining or reworking cybernetics project.
Yeah.
That'd be a nice, like, very, very popular, very accessible thing to reference. It was just comical as someone who knows that, and it's sort of like this mildly esoteric knowledge, and then people talk about it, and then there were like questions in the comments about it. I was like, oh, what is this? Like, well, it's like, well, this is. I made a joke remark that's serious and not offensive, but like, yeah, this conversation would probably have happened 100 or 80 years ago, exactly the same way, like with no difference in the words that were used, and it's quite funny that was the case. So anyway, that's my other bonus remark for this week, and for next week, I might talk a little more about the fellowship and flesh out as we talked about with publications. I want to flesh out the roles and the internship stuff. And I have a lot of lab manager work to do. I'm probably going to send you a lot of things in Slack about my updates over tonight and tomorrow, especially Sunday. So that's my plan. But yeah.
Okay. Sounds good. Okay. Have a good
All right.
week.
And thanks everybody who was here. And I don't know how many people got to see things earlier, but there are a lot of conversations with people this week I didn't get to, but I'll mention them next week. So take care, everybody.
Hey, take care. Have a good week.